If you're just joining us, welcome to Universe Vault Project, where we dive into the most fascinating secrets of space, stars, and cosmic mysteries. If you haven't subscribed yet, now's the perfect time, because today, we're exploring one of the strangest facts about our closest star. The sun doesn't spin like a solid ball. In fact, different parts rotate at completely different speeds, almost as if it has its own rhythm. Does the sun really spin? We often think of the sun as just a glowing fireball in the sky. But in reality, it's a dynamic rotating powerhouse made entirely of superheated gas called plasma. And unlike Earth or other solid planets, it doesn't spin uniformly. This unique behavior is known as differential rotation, and it plays a huge role in shaping solar activity. Why does this happen? Because the sun is not solid. There's no fixed structure holding everything together. Different latitudes rotate independently, like a liquid ocean with waves moving at different speeds. Rotation times: equator, 25 days per full rotation. Mid-latitudes, 27 to 30 days polar regions, up to 35 days or more. A fun comparison. Imagine if your head spun faster than your feet. That's kind of what's happening on the sun. Historical discovery. Galileo first noticed this phenomenon by tracking sunspots across the sun's surface. They moved slower near the poles, revealing the sun's uneven spin. Why does it spin at different speeds? So why exactly does the sun spin unevenly? It all comes down to its structure, or rather, the lack of it. Physical explanation. The sun is made of ionized gas, so it doesn't behave like a rigid object. Plasma flows differently depending on depth and latitude. Some areas move fast, others lag behind. Magnetic fields also play a role, stretching and twisting as the sun rotates. What happens because of this? Creates magnetic tension, leading to sunspots, solar flares, and even coronal mass ejections, CMEs, which can affect GPS, power grids, and satellites. Thought-provoking line. It's like a giant cosmic engine, with each part working at its own pace, yet still creating something beautiful and powerful. How does this affect Earth and space weather? You might be wondering, how does this uneven spinning affect me? The answer lies in what happens next. Solar storms and space weather. Differential rotation stretches magnetic field lines around sunspots. Eventually, those twisted magnetic fields snap, releasing massive bursts of energy. These eruptions cause geomagnetic storms on Earth, affecting GPS, power grids, and satellites. Real-life example. The Quebec blackout of 1989 was caused by a solar storm linked to these magnetic disturbances. Imagine losing electricity for hours, all because the sun wasn't spinning evenly. Why scientists care? Understanding differential rotation helps predict when dangerous solar events might occur. It also gives clues about how stars evolve over billions of years. Do other stars spin unevenly too? The sun isn't the only star with this strange behavior. In fact, many stars across the galaxy show similar patterns, though not always the same way. Young stars rotate incredibly fast, sometimes completing a full rotation in just a few hours. Produce intense magnetic storms and solar winds. Old stars slow down over time. Their magnetic activity fades, become more stable, less violent. Good news for any potential planets orbiting them. Neutron stars. Some spin hundreds of times per second, faster than a blender blade. Known as pulsars, they act like lighthouses in space. Philosophical insight. Just like people, stars age, change, and evolve. Their spins tell stories from billions of years ago, waiting to be decoded. The sun may look like a simple glowing sphere, but beneath its surface, it's a complex, ever-changing star with a dance of plasma and magnetism. Its uneven spin shapes not just itself, but also affects us here on Earth, and even deep space missions beyond our planet. If you want to uncover more secrets of the universe, subscribe to Universe Vault Project and hit the bell so you never miss a new episode. We bring you real science, explained simply, and packed with wonder. What would happen if the sun suddenly started spinning faster? Or what if it stopped altogether? Let us know in the comments, and stay curious.